get-go because nature's picky about rings, so like, really only one of them is gonna be like favored or potentially possible. So let's see. Let's pretend that I already made this into, it's enol. Yeah. Yeah. We are gonna do an attack from here, right? Because we can't just take bonds, or we can't just take our arrow, and it has to come from electrons, right? It can't just come from the carbon, because the carbon doesn't have a lone pair. So it comes from this double bond, but like, it's attached to that carbon, because this carbon is gonna be made happy by that coming in there. And then, what do I have to do here? Kick pi electrons up, and we get that. And we get, actually, that's not going to go there. We're going to tack that on at the end. So I can draw hexagons, but only if they get to be regular hexagons. We're going to number this 1, 2, 3, 4, 5. That's how we're going to do this. So 1, 2, 3, 4, 5. All right. This was our nucleophile. This was our, too many markers. Electrophile, which is convenient because they are lined up right, just perfectly to make our new bond right there. This electrophile already had this going on. And this guy has 2 hydrogens left, so, and then 4. That, and 5 has, we put those numbers on the inside. 4, 5. 2 hydrogens left, and a double bond to an oxygen there. So we've got this, right? Then to dehydrate this, well, all right, that's after just this step, right? We can go, well, here, have a hydrogen. Now we've got an alcohol. And then we can go, hey, you know what? We can do a nice little thing where we go like this and like this. And basically, so I didn't actually draw anything stealing the hydrogen, or the proton here, but, and we're not going to assume this specific oxygen steals that proton because that would be another 90-degree angle situation, right? So he's not going to steal this proton directly, like while it's still attached there. 90-degree angle, 4-member rings, not so much fun. But like, there's water and stuff around. Eventually, you're going to end up able to protonate this, to kick it off, and deprotonate this, and you're going to kick off water, and we're going to get that. Yes?
So how is that OH able to grab that hydrogen? Is it that hydrogen's just acidic, or?
So basically, well, yeah, so this hydrogen's still acidic because it's still alpha to this,
Yeah.
right? So basically, I think what happens is water's or we're in base, so base is going to go ahead and steal this proton, deprotonate us, and get us a new stage where we've got, sorry, you can keep asking your question. You had more of a question.
Oh, no, that was it.
Okay. 1 hydrogen and a negative charge there. This guy, 1, 2, 3, 4. So he's got that OH, but nothing else. And that became H2O, which is convenient because, well, I don't want to protonate that to make it we're in basic solution. So we're in basic solution, and we're gonna say OH gets to be a leaving group because, you know what, honestly, OH, I don't know, did you guys learn that OH like isn't a leaving group, like as a rule in first semester?
It's not a good leaving group.
Okay, yeah, it's not a good leaving group, thank you, all right. I remember learning like, OH minus is not a leaving group, and then getting all of this like, except these things happen in base, and I mean, do you think we protonate an alcohol in base? Well, okay, I mean, an alcohol is like pH 15, but that's not what the pH of, or pKa, but like that has nothing to do with the pKa of a protonated alcohol, right? pKa of an alcohol is just, can I remove this to make a negative charge? Can I add another proton to that to make a positive charge? Has nothing to do with the first pKa, it's a whole separate thing. So like, water's not a great leaving group, or OH is not a great leaving group, but it's good enough, especially if we've got, you know, very basic solution. Oh, see, this is very crowded. That's a lone pair, and we'll put the negative charge in here. There we go. So now we can go, hey, what if this lone pair went there? The only thing left to do is to kick that off because there's 4 bonds and 3 of them are to carbon. So, I mean, that's a good enough leaving group to get rid of a negatively charged carbon because we don't particularly like those. And then we get that. But, and then let's see, this made water because we protonated our OH, but then at this point we get OH minus leaving. So it's catalytic, right? Deprotonating this one required, I think the first aldol, yeah, so this dehydration is catalytic, right? Even if it's base promoted. I want to say, we learned yesterday that the aldol reaction, okay, no, the aldol reaction we still reform our base. I forgot, because this guy needs to get protonated, right? So we have OH minus that deprotonates here, turns into water, but then we use that water to protonate this O minus to turn it into an alcohol. So catalytic, we reform our base or acid. Yeah? Sorry, it's kind of messy. Okay. Let's see. Retrosynthetic analysis. So, say I give you something, and I'm like, hey, how about you make this for me? And I'm nice enough to tell you, you should use, I say nice enough to tell you, but I'm not gonna put something on your exam where I'm just like, hey, make this for me, and that's it. That's, you know, not pedagogically useful, panic-inducing? Is that the correct educational term? So, retrosynthetic analysis. I might draw something on your exam and say, hey, make this for me with an aldol reaction, or an aldol reaction and then a dehydration. If I say make this for me with an aldol reaction, but like clearly it needs a dehydration after that, just assume that I meant the dehydration step to be in there, because like, I don't know, I say aldol, I will try and make sure that I write these things very specifically, but like, to me, I don't know, aldol just includes dehydration, and if you're not gonna include the dehydration step, you like specifically say so. So, we can take one of these guys, and, okay, that is 2. From here, I can't see that double bond, alpha and beta. I don't know what it is. It's probably because it's highlighted or something. That looks like 1 bond, and I was like, this is not what you do. I'm sorry, I need a little better glasses. Okay, so, I know that that's like everything on the board at once, which is a lot. So, let's start with this. Oh, we're gonna have, what do we have? R R1, R2, R3, R4. Cool. And that. And then, in case I don't just tell you this can be made with an aldol, do it. In case I give you one of these and go, could you make this with an aldol? I don't know. You have to count, right? So we don't count at numbers because this is organic chemistry and I don't know, we just like to make things difficult. So we count in Greek letters. Carbonyl carbon, alpha, beta, right? That's a beta. It's like a bee but with a tail. And it's sideways, but you know, whatever. So yes, we can make this with an aldol, right? In order to know if we can make something with an aldol, we look for an alpha beta unsaturated carbonyl. Yeah, it doesn't have to be an aldehyde, it can be a ketone too, but alpha beta unsaturated carbonyl. Then what we do is we go, all right, well, we know that this is the bond we end up breaking. So, or that's breaking. That's the bond that we end up making, right? Because we're doing retrosynthetic analysis, so we use this funny arrow, and I keep talking about breaking when I really just mean to undo. Like, that's what we would break if we were undoing the reaction in exactly the same way we're trying to do it, you know? So, that's where the new bond was formed. We also know that the step before that, we have, let's see, let me draw this. R4, R3, that, R2. And before that has a double bond, we have, I don't know where to put it. Right? So the first step we do is we go, well, we know that in order to get to this double bond, we do a dehydration. So what do I need to add to this guy to get the starting material for this reaction? An OH and an H. So the OH comes with its own electrons, right? The H does not come with its own electrons. So we have only one set of electrons. That's okay. That went to the proton here. And then OH came in with its own electrons, so we have the right amount, right? And then that would just be doot to get back. But we still need to figure out how we would make this in the first place. So the bond that we formed when we made this, or the bond we want to break to undo this, is still that one, right? So now we draw these like separately. And we go R3, and we can color these guys if we want to kind of give us a, an idea of things. And we can number these too. That can really help because it's really tempting to draw, like, because this is a carbon, it's really tempting to draw that line. But we're breaking that line, right? So there's a carbon at the end of this if we just end this here, or just do the up. We don't have to go that way. If we go that way, we're accidentally just adding a carbon. So we're going to draw this side. I'm going to draw it red. That whole thing gets to be red. R3, R4, that was the thing. And it already had one hydrogen, but, oh, it had another proton, because that's what we deprotonated, and this is where we got our electrons to make that new bond, right? So then what we're left over with is, honestly, I would not number the alcohol. I would just start at one end or something and do 1, 2, 3. In this case, we've got R1, R2, that's 1, 2, 3. 2 is where we put that. And there we go. This guy does not get another a hydrogen or anything because, well, we started with 4 bonds, But this guy went back to a double bond, so we didn't need to add a fourth bond. Yeah? All right? So that is how we do retrosynthetic analysis for, well, not necessarily just crossed aldols, but any aldol reaction. So make sure you can do these. I like these. I'm not going to make you, like, I might make you do this, I might make you do this retrosynthetic analysis. I'm not going to make you, in the same problem, do this retrosynthetic analysis and then draw me a mechanism, because that's, like, a lot to do in one question. Also, I think for the next exam, for all my mechanism questions, I'm going to give you the products. That way, I mean, I've already got like usually 2 pages of can you guess the products. So we've already established whether you can guess those. So I think, yeah, for the mechanism questions, I'm gonna give you the products and you guys are gonna draw me the mechanism, which does mean that it's going to be, I'm either gonna make it worth less points or each part of the mechanism is worth more points, just because I used to make it like half of the points, or like, I think I made it, yeah, 6 points. So on your 20, we won't go through the next thing, but on your 20 point, on your mechanism question that was worth 20 points, I gave you 6 points just for getting the product, which, you know, is a nice hefty chunk of the points. So I'm either gonna make your mechanisms worth slightly less, or just mistakes are higher stakes. But either way, I think it'll help. I think that'll be testing what I want to test, because, I don't know, I mean, you might totally be able to do mechanisms, and if I picked one of the things where you're like, I have no memory of what the products of this are, that's, you know, a problem. So, yeah, I think that's how I'm gonna do mechanism exam questions in the future. Make sure you can do this as well. And I know that in my first exam, I have retrosynthetic examples, not of aldol, because, God, that was a slower semester and we had 3 exams. So that was like, I think just like, I don't remember, or was it in the second exam that I had? No, it was in the first. They were like Grignard reagent things or something like that. I had some sort of retrosynthetic analysis, and I had a multiple choice where it was like, here is set 1, 2, 3, and 4 of molecules. Which of these can make it? Maybe more than one. I might do that, but I honestly might just make you draw them for me. In which case it would be worth more points. I would assume it would take much longer, and you would still have, that would definitely still be part of your choose your own adventure stuff. It might still be that, like, well, okay, no, it won't just be aldol. Choose your own adventure, but they're all aldols, because we've got some other condensations here too. But to be fair, Claisen condensation is pretty similar, so, you know. All right, have fun, have a break.